And so the next panel is one of my favorites. It's the most desired panel. Now, I always joke with people, right, that, when people think of AI, someone comes to mind. People think of social networking, someone else comes to mind. People think of hardware and PCs, someone else comes to mind. People think of networking and internet. We don't glorify our inventors, right? There are only two things that matter in the world: internet and mobile, right? Well, guess what? We have a panel of the inventors. And these, and you won't see them anywhere else together. And before I even get to the panel, I'm going to have a quick introduction. Each of these folks will come and talk, and then we will have a very good discussion of where things are heading. And before I go, and just watch this, let's play a first introduction video of Dr. Jan Uddenfeldt.
My name is Jan Uddenfeldt. I'm the former CTO of Ericsson as well as of Sony Mobile. I've been in the wireless industry for 35 years. I always liked wireless because it's kind of a natural way of communication. So I started with research on what became GSM, and it was a great vision we had to make really handheld communications. It required a lot of complicated signal processing. It started in my lab. We were doing some early trials with TDMA technology. GSM was a big success, and it became much bigger than we ever thought. We needed a new technology for internet access, for wireless internet access. It's been really great for me to be able to innovate so many times with new technologies and to see how successful they have become in the market.
Please welcome Dr. Jan Uddenfeldt and tell us where things are today.
Okay.
And I'll come back right away.
Thank you. Well, it's great to be here. Thank you very much for inviting me. And of course, yeah, this decade been really full of innovations. That was more of the past, and I mean, I'm based in the Valley nowadays. I've been here the last 15 years. I work mostly with a lot of startup companies. I would say that innovations the last decade, I would focus on two things here. One is 5G, and another one is AI. Of course, I'm a wireless veteran, so I kind of start with the 5G thing. And I must say that 5G means a lot for the wireless industry. It takes the whole thing up to a gigabit speed, and that makes it very competitive to everything else. And that has also kind of is implying that it's not only mobile any longer. It is things like fixed wireless. It's things like private 5G for enterprises. So it's really broadened its scope dramatically. And so it kind of started a couple of years ago, and now it's like 2 billion users. So really, I think the thing now is very much on everyone's mind is cloudification and openness. Of course, when 5G started a couple of years ago, didn't really include that on the RAN side. Of course, it does on the core side. On the RAN side, it's a little bit more complicated. You have things like radio MIMO and a lot of these things that makes it very complicated. But I think now it's starting to happen. I think cloudification and openness. The question is, of course, what will go first and how will it really be deployed? I think personally, it looks a lot like what is going on here is that cloudification is actually kind of more like the driver, because it's kind of obvious that you do a lot of cost savings by going there. And openness is a little bit more like a follower, although of course you need openness to the radio interface. So I think all of this is happening. We saw that big announcement by AT&T a couple of months ago. I think that's like a starter. It changed the game a little bit perhaps, but nevertheless I think it's kind of doing cloud and open almost at the same time. I think that's what you have to remember. This is not trivial. We've seen it in the past. SDN, NFV, and all of these things, it just doesn't happen overnight. It's a little bit complicated. You need integration and a lot of these things. But I think the main point is it's kind of happening now. And we'll see at what pace it takes, but it's definitely completely different than a couple of years ago. And of course, AI is very important from many points of view. It's going to have big impact in 5G networks. Things like automation and of course, network planning, all of these things are happening. And I think it's going to have a really big impact on what's going to happen next on 6G. And I think that's definitely something that is extremely important. And then, of course, we can look upon this from different point of view. That's a kind of network view. But then the question is, okay, so what are you using this for? And what are the driving forces, really? And I was here and talked a couple of years ago, and we talked a lot about driving forces for 5G. Should be like AI and VR and AR. So I think some of that is really playing in. And I think it's also important to realize that one thing that happened much faster than anyone expected was the fixed wireless access. It is just because it's high speed. And most networks is not really gigabit speed necessarily, but almost. But it's getting there, especially if there is more spectrum allocated. It will be higher and higher. But definitely that's like almost like 10% of the households. It's like 10 million are just in US. So I think this is kind of definitely going much faster than anyone expected. And then, of course, looking a little bit forward, we can see that things like AI will definitely drive more than what people expected. I don't know about XR. It's a little bit more niche, a little bit more vertical, and we'll see how that will evolve, actually. And I think it's also important, that's for consumer. So it's mobile and it's residential, but also for enterprises. We have the same thing there. We have private 5G. And private 5G is like many things. It can come from the operator, or you can build your own network. If you build your own network, then you have spectrum available to do that, which is kind of helping a lot. If you do it with the carrier, there are things like slicing that helps things. And then there is another thing happening, and that is open network APIs, to really build applications on what is available in the mobile network. So opening up APIs like and of course, we have the whole Camara initiative, and it's called Open Gateway when you talk to operators. And I think that is those things will also drive a lot of things going forward. So there is a lot of momentum here, and I think I'm definitely looking forward to what is happening next. Thank you. There you go.
Thanks, Jan, and really exciting. Thank you for getting us into the mobile era. And obviously, everybody is kind of, using phones to take pictures. I'm sure you didn't envision that when you were inventing.
No, I think you're right. We didn't think about that. It came up a few years later, but it's like 20 years ago anyway. We started with that. You're right.
That's right. That's right. Thank you. And we'll get to where things are heading when we get the rest of the panel. So the next speaker is the creator of connectivity within the internet. So you invent the internet, but if you can't connect, it doesn't matter, right? So that's what she has done. So please welcome on stage Radia Perlman.
Internet working icon. She developed the algorithm behind the Spanning Tree Protocol, a system of schemes and rules for communications transmissions between networks and devices, which led to the geometric layout of workstations, including connecting lines for Ethernet networks and optimizing its bandwidth to link to large clouds. Her protocol design is still used for routing IP today. Her textbook, Interconnections, made a science out of the field of network protocols. Owner of more than 100 patents, a National Inventors Hall of Fame and Internet Hall of Fame inductee, Radia Perlman. Genius.
All right. Thank you. Thank you. Please let us know.
So it wasn't like I knew from the time I was born I wanted to go into computer network protocols. I just happened to stumble into the industry at exactly the right place and right time, which was at the dawn of networks and at Digital Equipment Corporation. The job I got was designing routing for DECnet, and that was so much easier back then because I didn't have to fight with standards bodies and all that. It was kind of what I designed got implemented. Although what I did was routing for DECnet, a good routing protocol doesn't care whether it's routing, Italian or German or whatever. It can route anything. So indeed, it is being used for IP as well. So sort of conceptual, rather than the specific protocol, some of the conceptual things that I had done. One was self-stabilization. What that means is I looked at the ARPANET routing protocol and I realized, oh my goodness, a single bad packet in there could bring the network down forever. And we're used to our PC getting into a weird state, and so you just turn it off and turn it on again. You can't do that with a network. The way that you fix a network is by sending network management messages across the broken network. So kind of my first paper was, hey, networks have to be a lot more resilient than like a single system. And this was the flaw in the ARPANET algorithm. And this is how to build an algorithm like that will be self-stabilizing, meaning once you get rid of whoever's corrupting packets, the network should return to normal operation. Another thing was simplicity and ease of management. I actually kind of hate technology. I can barely use a smartphone and things like that. So I design things for people like me, that they should just kind of work. And also scalability. I did some things that made it possible, instead of having a network with a few hundred nodes like the ARPANET, something that really could scale to the whole internet. And what's ironic is what I'm mostly known for is the spanning tree algorithm, which was a hack that I thought was a bad idea. It was, it was done to correct for a mistake that the industry had made, which was thinking that Ethernet was a network instead of a link in a network. And indeed, we shouldn't, with spanning tree, it's now a layer 3 protocol, meaning there's something that forwards from link to link to link, even though you call it a layer 2 protocol. So it's kind of a complicated but fascinating question. Why do we have 2 layer 3 things? Why do we have both IP and Ethernet? And we shouldn't need them. IP, unfortunately, we settled on IP, where every link, if you move from one side of a router to another, you have to change your address. But that's just an idiosyncrasy of IP. If we'd gone with a different protocol in 1992, like it was proposed, then we wouldn't, the Ethernet header would go away because we're no longer using the shared links. But anyway, the internet. 5 years ago, I was so enthusiastic about the internet. I could wax rhapsodic about how you could reach a global customer base. You can buy a widget from some merchant you never heard of in a country you never heard of, and you pay money and somehow it appears. But now I think it's the end of civilization. People get so wildly nasty, when commenting on things. Civilization is so polarized because you can tune in just to information that you want, and there's algorithms that want to keep you engaged. And my God, if they tell you anything that isn't what you already believe, you might stop reading. So they just give you more and more extreme things. It's sort of the end of truth. What is truth anymore? So how can we avoid this? Well, I don't know. If I knew, then all of you people would have nothing to work on. So isn't it great that we're leaving you with important problems? So geeks can certainly attack things like building equipment that's cheaper, faster, and more energy efficient, getting more wireless bandwidth, getting more wired bandwidth, changing our public key cryptographic things to be quantum safe. If there were quantum computers, RSA and elliptic curves, the public key algorithms, just those, would no longer be safe. But whether or not there ever will be a quantum computer capable of breaking these things, we need to replace them with new ones, which are just ordinary algorithms that work on ordinary computers. I wish the NIST had not called them post-quantum algorithms, because people think, oh, okay, after all of our laptops are quantum, then we can think about these other things. I don't know. And fighting buzzwords. So that's, you know, a pet peeve of mine is suddenly a buzzword appears and everyone starts using it and I have no idea what it means, and I'm willing to sort of admit that I don't know what it means. Most people are just kind of terrorized that, oh, everybody else seems to understand it and I don't. So I think that's it. Thank you.
That was very good. Excellent introduction to where we have come, and we'll get you on some of the questions on where we are heading, especially on quantum. All right, so the third panelist I want to introduce, I'll introduce with a video, but this is a very different video, and it's Martine's one of the first presentations at this event itself. It used to be called One Summit. Probably 12 years ago, 13 years ago, somewhere in that range. And I just took like a small clip from that to see, what he said, is it true or not, right? So that's kind of the test. So let's roll the video.
And so we kind of came up with this totally, like if you looked at it, gave this to a system programmer, this totally kind of humdrum simple thing, right? You've got a generalized hardware. You got some hardware abstraction layer that says, okay, well, here's kind of a higher level interface to this hardware. You decouple the control logic so you can have whatever distribution paradigm you want, and then you've got a control application. And I know you guys are totally familiar with this slide, but I wanted to put it in the context of what it arose. Right? And there's two problems we were interested in. The problem was here to generalize this and to decouple that. That's it. So anyway, before there was OpenFlow, we had a hard time getting switches, so we'd actually run to Fry's. And we'd buy like whatever cheap servers there were. So this is actually one of the early ethane prototypes. And so we have like 4-port NICs and their switches. This was actually over in Gates 353.
All right. So Martin Casado, please come on in. All right.
Thank you.
Thank you.
All right. Okay, I'll be quick. Let me just give you just a little bit of history. So first job out of college was actually working at Lawrence Livermore National Labs. I did computational physics. I was in the weapons program, actually. I started in '99, and 9/11 happened. And so I actually had all of the clearances from being in the weapons program, and kind of like the tenor of like the government change from like this anachronism of the Cold War to like more the intelligence game, and so they moved me to the intelligence service, and I worked for the intelligence service from Afghanistan through Iraq, right? So like two like actual war efforts. And as part of that, like, we'd actually do these kind of missions. I was like the nerdy guy in the back, and I remember thinking like, wow, like, and this is the time when things like SC Linux came out. Like with operating systems, there's a lot you can do. I was actually a programmer. I wasn't a networking person. There's a lot you can do with kind of like, like the servers, but like when it came to like providing strong guarantees in the network switches, kind of like what you got from Cisco is what you got, and like I kind of dug into that a little bit. I'm like, there's actually not a lot of flexibility at the very low level. So I popped out of that, and I went to Stanford to do my PhD, and this is the problem that we looked at, which I talked about before. And we were really just trying to solve two problems. The first one is at the time, you had one of two options. I could buy a forwarding switch from a switch vendor. That forwarding switch actually had the tables kind of like chiseled in, like you got your L2 table and your L3 table, and if you want VLANs, you have your VLAN table, and et cetera. And like even replacement policies were there. Like you could have that, and you would get great cross-sectional bandwidth. You get 48 ports of 1 gig or whatever. Or you could buy a server, and you get x86, which is great. You can do anything. Every packet, you can do a whole bunch of stuff. However, like you get 1 port of gig. So one of like the areas of exploration is like, can you do something in between where you do get 48 ports of 1 gig, but you can actually modify a whole bunch of stuff? And so that led to OpenFlow and then eventually P4. The second thing we've focused on is, okay, it's great to like make everything fully distributed. That's great. And it solves the internet problem. And like Radia, who's one of my heroes and has long been, has done all of this great work there. But what if I didn't want to actually what if I wanted to actually have some guarantees because I'm doing something special? And this was kind of based on the work that I did. And so then we said, okay, well, if you want to put guarantees on global shared state in the network, you have to have a bit more to work with. Like maybe you want to do versioning, or maybe you want to put type bounds on kind of updates or whatever. And that's when we kind of decoupled not just the management plane, which had also always been decoupled, but the control plane, and we started kind of looking at that. And that led to this company, Nicira, where what we wanted to do at Nicira was solve the problem of network virtualization. So if you think of compute virtualization, in compute virtualization, you've got a physical address space, and you have a virtual address spaces, many virtual address spaces. And these virtual address spaces are mapped kind of in real time to physical address spaces. And these virtual address spaces, they look like their own universe. So in order to do that sort of a mapping where you're taking kind of virtual to physical and it can move all around, and you can never have them kind of overlap or like packets go between them, you actually need just stronger guarantees. And you've got one of two ways to do this. You can kind of really constrain the network, so like it's actually enforced in the topology, or you can come up with a general programming paradigm, which is what we focused on. So we did that at Nicira, ended up getting acquired, and then I ran that business for a while. And then I joined VC, and I've been a VC for the last almost 10 years now. So let me talk about something entirely different. So I'm going to use the last 1 minute to describe why AI is actually important, which I know this is a big, huge departure, but I just think it gets lost. So I took my first AI course probably in the late 90s, right? I've taken a lot of AI courses, and we've had these summers and winters forever. Like I remember when I joined Stanford, and Sebastian, this is in 2003, Sebastian Thrun had just like won the DARPA Grand Challenge, and we're like, amazing, self-driving cars are going to show up in like 2 years, right? And this was like, $75 billion of investment in 20 years ago. So we always have these kind of like winters and summers for AI, but we've never had this kind of wave of AI companies. Like, where are all the AI native companies? Like, where's the transfer? Like, where's the internet era of AI? And why haven't we seen this? And if you actually dig into it, it just turns out the economics are terrible. like maybe you'll get something 10% better. There's like perverse economies of scale. There's diminishing returns. It's just something that's like great for like big companies to invest in and get value, but like for startups, it's terrible because the economics are very bad. So this is the one thing that's changed. Actually, it's just like we've actually found a use case where the economics are eye-watering. And so let me kind of describe with a very silly description, but it actually generalized, which is if I wanted to create an avatar of myself, like as a Pixar character, like I could get a designer, it costs what? Let's say $200 in 2 hours. The inference cost of generating an image for me, like the actual inference cost, about 1/100th of a penny right now, right? So this is 4 orders of magnitude difference. And I know that seems like a very silly example, but it turns out like all content creation follows in this, whether this is music, whether this is text, whether this is language reasoning, whether this is 3D meshes or textures or characters or whatever it is, right? And so one way to actually think about what's going on right now, which, because you're networking folks, I thought it would help, was anytime the marginal cost of something goes to 0, the use explodes enormously. And we've seen this twice in the past, right? So with a microchip, we brought the marginal cost of compute to 0. Rather than like people actually sitting in rooms calculating logarithms by hand, we had ENIAC that showed up, which by the way was 4 orders of magnitude faster than human beings. That was the compute revolution. The marginal cost of compute went to 0. With the internet, the marginal cost of distribution goes to 0, right? And so before, we like kind of ship stuff in boxes. It would take a very long time. By the way, if you actually look at the price per bit, 4 orders of magnitude faster or cheaper than if you actually send it. And so with this AI wave, the marginal cost of both language reasoning and content creation is going to 0. And that's why this is like actually creating like these very solvent businesses. You're seeing a lot of shifts. So I actually do think we're at the start of the super cycle. I do think it's very, very similar to networking. And so I think this crowd of anybody would appreciate that. And that's it.
Very good. Very good. Thank you. All right. So this is, again, the best time for me asking you all, right? Like, first of all, thank you for inventing all these things that we are now hooked on today. So thank you or whatever. If you're not happy, then that's a different problem. But Radia. But let me ask the first fundamental question that everybody is looking at your bright minds to. Where are we heading? Like, what are the top problems in the next 5 years that need to be solved so that these guys can actually update their resumes with the right skills? I mean, that's pretty much it. Let's go with
Okay.
Jan.
Well, I think definitely. I think those 2 areas that I talked about, are extremely important. AI, I think, is going to continue to change a lot of things. And I think it's going to be those profound algorithms are going to change a lot of things that we are thinking about today. And of course, what we see now is just the kind of first things happening. And I definitely see it will come into networks in a more profound way to solve some of the problems we are thinking about ourselves. But it will definitely also be very good for the consumer to really drive this and use it, generate traffic, and all of these things. Enterprise is yet to be seen, of course, how it will be developed. But nevertheless, I think that's going to be a tremendous driving force. I think the other thing is this 5G stuff. I think it's as I was trying to say in my speech, it is kind of not only mobile. You know, you have to think about it a little bit differently. This is also solving problems for fixed networks and for like private enterprise things. And I think this is such a strong network in itself, and of course with the enormous volume number of users you have behind it is driving down cost. So from that point of view, it's not wrong to think about network on network. I think it's a thing one can really think about, and that means it's coming in more profoundly. The kind of 5G protocols are coming in more profoundly into other networks, and I think that's something to really consider going forward.
And you think AI will make it all the way into, I mean, it's already in the mobile device, but you know, from a RAN and connectivity perspective, that's sort of as we move to 5G and 6G. Is 6G and AI like a match made in heaven?
Yeah, I think so. I mean, I think it will help definitely, and I think AI is going to be very important in defining 6G. Yes.
Standards. Okay. Very good. Radia, what do you think? Where are we heading?
Okay, well, one thing, quantum is, you know, you hear all the time, and there's this misconception that anything that runs on a classical computer would run a gazillion times faster on a quantum computer, and that's completely false. There's sort of a very narrow set of problems that a quantum computer would do better. Like they can factor numbers, and it's like, well, who cares? I don't need to factor numbers, but that's what our public key algorithms are based on. Now, saying something a little bit controversial, I suppose. So I can behave like a geek. I can also understand what it's like to be human. And so I was... Right. So I was once presented with a survey saying, what do you think of 5G? Would you change providers to have 5G? And as a human, it's like, do I need another G? What does that mean? And as it turns out, the only thing 5G gave to me, which I'm not really into watching movies on my smartphone or whatever, but was that I had to throw away my smartphone and get a new one. So you can do a better job of selling these things than saying, oh, wow, you're going to get another G, you'll get 6G, isn't that exciting? You have to sort of more tell them what they're actually getting for it that they couldn't do before. So I don't know.
I like the dialogue here because you can see subtly how mobile is going after fixed and how fixed is going after mobile. So but that's great. That's good. Thank you for that introduction. Martin, you already talked about AI and where things are heading and the economics, but 5 years from now, I mean, you are also one of the top VCs here in the Valley. What do you see? I mean, other than the incremental improvements of the companies that come on board, like what are some major things that we should all be aware of?
Honestly, if I was to choose the top problem to solve, it's not a technical problem. I think that the United States has gotten into the world's gotten into this very, very funky space where we use the precautionary principle first and innovation second. And listen, I remember the early days of SDN. I was in this, like literally, by the way, the video that you showed was 2009, right?
Oh, so it's even further out. Oh my God, okay.
You know, and at the time, like, listen, like, it was like, we were the good people, right? And it was like for like openness and innovation and like, like breaking down the walls and like bad mainframe and like the academics were there, and the researchers were there, and the open source community was there. Like it was just amazing. And listen, I'm old enough. I remember in the 90s, like when this was kind of the same thing. And like we're against Unix and open source, and like we're against the crypto regulations. Like I remember that. I remember the DMCA stuff, and like it's gone. Like I swear, all of that is gone. It's just the most amazing thing that we've got these new technologies, like for example, AI. And somehow we've decided that we're going to like regulate before we actually innovate. And I mean, there's a bill passed yesterday, SB 1047, which we're basically saying like, you know what, these top models are dangerous. It should only be big companies that do it. And so listen, it's not surprising that policymakers or regulators do dumb stuff. Like they've been doing this for my entire career. What's surprising to me is how silent everybody has been. They're very, very, like the academics are totally silent. The open source community, I mean, they're always kind of a little bit kind of vocal, but like not like they used to be. The researchers are pretty silent. So honestly, I think if there's one thing that we need to solve as a community is we need to step up and realize that innovation is very, very important. And like these types of things of like doing precautionary first, the principle first is a bad idea.
Yeah, and I think when people see the impacts of innovation, they realize that there is a good side and a bad side, and the good side will always kind of outrun the bad side. So
they don't recognize it anymore is the problem. I mean.
Excellent. So again, we've heard the theme of kind of continue doing what you're doing, bigger, better, faster, cheaper, more energy efficient, some disruptive technologies, implementation of AI inside. What do we disagree about as leaders? What do you disagree about in your daily life? I heard a little bit of fixed or mobile, but what else? Anybody can jump in. Jan, you want to start?
Well, I mean, excuse me, a little bit cold in here, isn't it? So sorry about that. No, I think of course, the G's, of course, they means less and less when you just add another G, right? I mean, going from 1G to 2G was more important and so on. So I think, of course, it's a very relevant question to ask. What does it bring you? And that's why I think it's important that I kind of talk about this from a different context, that it's not only mobile, it's actually more than that, and it may have other impacts. So I think it's just like modernizing a network or whatever. I think we have to see it that way. And then I think the other thing you brought up, Martin, I think it's profoundly so important. US is really driving innovation and has to continue to do that. Europe losing a lot of speed. Europe are regulating like crazy. Do not let US copy that. I agree on that. So I don't know what we disagree on. I don't know.
Well, that's all. Great minds agree.
Okay. So yeah, this was more controversial a while ago, but yeah, this buzzword happens, and then everyone thinks it's the most important thing ever. So I'll talk about blockchain, which, it used to be that everyone just sort of knew that blockchain was the future, and if you could somehow cram blockchain into any application, it would then become secure or efficient or whatever they thought they were getting out of it. And so, I have like a whole talk, lots of whole talks about various use cases and how they can be done so much better. So kind of the message that I give to the audience is don't say, here's this thing, how can I use it? Instead, say, what problem am I solving? Look at various ways of doing it and choose the best one. And someone said, well, that sounds very good, but my manager really wants me to use blockchain. I said, fine, do what I said, choose the best solution, and then just tell your manager you're using blockchain. He'll never know the difference.
That's one way.
I think the ledger will catch you on that, right?
Yeah.
That's a different problem.
So controversial opinions. Okay, so I'll do two very quickly. The first one is like, listen, I love quantum, it's great. I will tell you, I was a research intern at TJ Watson in 1999. Quantum was very exciting then. The next year was going to be the year of quantum. And then when I joined Stanford, there's another big quantum effort. This is in the early 2000s, and the next year is going to be the year of quantum. And when I joined Andreessen Horowitz, there was another big quantum wave. This is in 2016. The next year is going to be the year of quantum. And so it feels like there's some technologies like cold fusion where like you see these graphs and like we as like a species can't like read the asymptote and we're going to like wait forever. It's like, I think quantum may be one of like the ultimate Godot's of waiting for something that's not going to show up. Kind of like IPv6, to be honest.
Yeah. You're talking about IPv6 to this audience?
No, I mean, I like IPv6. It's just, you know, again, it's one of these things where, and then the second one, just very, very quickly, is I actually do think the cloud is finally disaggregating for the first time. And like we consolidated all of IT into these big clouds, the big three. And now, and I see it a lot from the private markets, especially because the actual compute and connection model for these AI workloads is different. We're actually starting to see it disaggregate into specialized clouds, into third-party clouds and boutique clouds. So I think we're going to see a big, big shift in the cloud.
Yeah. No, I think that's fair. So, like as we close the panel, any prediction or your closing statement, Jan?
Yeah, I think we covered a lot, and I'm very optimistic going forward. I think we definitely, we see so much happening the last decade, and of course it takes a little bit longer than you think. I mean, when everyone starts to talk about cloudification and SDN and openness and all of that. Of course, it takes a while, and it's a little bit more complicated when you do it in really big networks because, someone has to integrate it, and there are a lot of these things. But no, I think we are on the right track. We're doing great things, and then mixing AI into this, it's gonna be really exciting next 10 years. Absolutely.
I'm amazed at how technology keeps you going so long, for decades and decades.
Yeah, that's true, yeah.
Yeah, Radia, what's your take?
I'm going to speak on behalf of humans again. People say, it's the users, we need more user training in terms of security. They shouldn't click on suspicious links. It's like, what's a link? What's a suspicious link?
Yeah.
It should be safe to open up a PowerPoint attachment. It may say objectionable things to you or something, but it shouldn't infect your computer. You should be able to visit any website, and again, it could tell you horrible things or convince you, but it shouldn't infect your computer. In some cases, just merely attaching your computer to the internet infects it. And this is not the user's problem. It's we as geeks, we have to make these things safer. So, anyway.
That's very well said. Thank you.
Good.
Okay, so quickly, in 2002, I saw Linus Torvalds speak. It was one of his last speeches in Moffett Field. And we were there, and he gets up on stage and he says, I know 9/11 was really bad. I think this was like pretty recent. He's like, and like you do whatever you need to do there, but there's a bigger problem going on. And like, I was like, my goodness. And he said, right now, like they're trying to make open source copyright, and they're trying to do all of this legislative stuff against Linux. And I remember thinking, this guy's absolutely crazy. He's a foreigner coming to a country that's mourning. I was directly affected by it. Like, what is he talking about? And I actually think in retrospect, he was right. Like the battles that we fought then are why we're here now. And I do think that there's this kind of constant need by regulators to regulate in ways that don't consider the positive benefits of innovation. And by that, I don't mean like big company and big tech innovation, I mean little tech innovation, right? I think we're in one of those moments again, I really do. And so again, listen, I want to be all positive and talk about how great tech is, and it's great, and I love it, and I still do, et cetera. But I do think that there's a higher bit here, which is like, if you really care about tech, you really care about open source, you really care about openness, there's another battle to be fighting right now.
Excellent, and I think we all agree with that. This is why the conference is called Open Networking Ed Summit, and we have continued doing years of promotion on this. But thank you all, and I think it was, first of all, thank you for inventing things that we like. I always say, we need to glorify people that have created the world for us, right? Internet and mobile. Those are the only two things that matter. And then internet connectivity is kind of where your work goes, mobile. You saw the 2 phones in the video. And then disaggregation is how we build it, and he predicted that in, you said, 99, 98.
Oh, no, this is a huge group of people.
Oh, huge, okay, fair enough. But that's how that's why we always, these guys will always say, we created it, okay? That's okay. All right, so thank you very much, and thank you for coming. Appreciate your time.